Hello, and welcome to this seminar as part of the KTH Africa Days. My name is Viktoria Martin. I'm a professor in energy technology here at KTH, and I'm very happy to see you here at KTH, but also thank you for attending via YouTube. I hope to meet you in person sometime. So today I will talk about EPIC Africa. So I think you can agree with me that Africa is a continent that is quite epic. It has vast amount of resources, a fascinating culture, rich culture, and it's an honor for me to be part of this project, which has been inspired by this richness. It's called Energy Planning and Modeling through Integrated Assessment of Climate Land Energy Water Nexus in Sub-Saharan Africa. It's a long title and it's funded by Horizon Europe and its collaboration with the African Union. So in this project we study the cases of the Volta and Tana River basins, which are both a resource to the countries through which they flow, the rivers, and we hope to learn a lot by studying these countries. So the project has partners where KTH is one. The project is coordinated by TU Delft. And then we have Vito from Belgium, Volta Basin Authority from Burkina Faso, UENR University from Ghana, and Calro, which is an agricultural and livestock research organization in Kenya, and last but not least TAMO, which is a hydrometeorological observation organization who works with collecting data related to climate and water and land resources. So I'm happy to start today with telling you about this project, and then after some presentation of 20 minutes or so, I will invite up here some guests. So I have been asked to leave their names as a cliffhanger, but I will tell you more about them in a minute. First, about the EPIC Africa project. It is a new project. Rather new. It's a 4-year project, started November 2022. And then we had a kickoff in Ghana, located in, we placed our meeting in Accra, but went on a tour and looked at the Akosombo hydropower station, part of the Volta River energy systems. And you see the happy people here. In a nutshell, and then as I mentioned, focusing on the Volta River and Tana River basins, this project is about doing an integrated climate, land, energy and water assessment to provide insights that can be used for energy planning. Many times energy planning is done in silo, with the focus being on providing electricity to meet the demand that is growing in this region. And when you do that, you may miss out on important points when it comes to other resources systems, such as water and land. And that leads to competition with agricultural sector and with competition about drinking water and other things. So we want to contribute to increased clean energy generation in the African energy system by working with these two cases. So hopefully the results will inform on the particular rivers, but also lessons learned for other similar cases. In an Horizon project, so it's not only research where we do modeling and so on. We also have proposed to take this opportunity to enhance local expertise. I wouldn't say that expertise needs to be built in these countries. It's more about enhancing local expertise to get them on board on some of the methods we have been working with for a long time. But as we do that, I am very sure that also the European partners will learn a lot about how you can transform a very complex energy system while caring for the rest of the resources. So we have a platform, various platforms here. We call them Transition Arena, where we will create a dialogue with expertise and local stakeholders to bring them on board to decide with us what should we study in particular, how should we prioritize when we build our models, because if we try to investigate everything, it's going to be too complex. And then when we come back with the results, do these results make sense? So it will be an iterative procedure over the years to come. And in modeling and analyzing these integrated climate, land, energy and water systems, we will also highlight environmental, social and economic trade-offs. So very broad take on this. To give you some example of what we are talking about here, we can zoom in on one of the case applications. Here is a map of the Volta Basin and look at its opportunities. So it's river, the Volta River and its branches running and touching upon 6 countries. But 80% of the basin is in Ghana and Burkina Faso. But a lot of the power generated from the Ghana power stations are also help feeding the electricity, so it's exported to the adjacent countries. So the whole area here is affected. It's a large area with a large mean annual flow, so that's good. We look for opportunities. And then already in place is a transboundary water cooperation. And this Volta Basin Authority had a convention in 2007 kicking this cooperation off. This cooperation is then looking already. So it's not that this is something new that is not known, but they're looking already at these trade-offs that exist between energy, water and food among the countries that are touched by the Volta River. And there are established institutions and regulations already in place. Some investment infrastructure is also available. But the challenges are also there. So it's competing uses, despite the regulation, despite the cooperation. If you have anything happening upstream of a hydropower station, you have a competition with power generation and perhaps irrigating. So if you prioritize irrigation in Burkina Faso, you may affect things that the power generation downstream in Ghana area. And while they are aware of the trade-offs between water, energy and food, there is really no optimized way on how to address these issues, how to take care of them, more just taking one issue at a time and trying to solve it. When you need to understand what's going on in this river, and fundamental for this cooperation is to have data, so that you can take a look at each other's data and see what's going on in Burkina Faso, what's going on in Ghana and different places, Ghana and the other countries. And here, the sharing of data is not settled. It's very much country internal. Also, they do have generation capacity, but there is no storage, really. Especially if you think of distributed storage is closer, a bit further away from the actual Volta river shores, aside from the dam. And then they have already started to see the climate extremes of droughts and flooding. Sometimes they have to open the floodgates. So far, I don't think there's been too severe, or I should say, there has been severe floodings, but not too frequent, but they expect that to increase. And drought, of course, then the competition between food and power generation increases even more. So that's the background, and more specifically then for our project, Epic Africa, we hope to bring now a structured process, engage stakeholders across the countries that are involved, and engage them in a dialogue through this transition space. Really just talk through what do we know, what's happening, and what is important to gain better knowledge on, and so on. And this is later to inform the modeling part, where KTH happened to be a part as an engineering institute. That this is where we are very active, whereas the local partners and also Vito are managing the dialogues. So far, so we are 1 year into a project, and I think Horizon projects normally are, you are a big consortium, you have promised a lot to deliver a lot, and it takes about a year to get going on how will we now execute all these fantastic ambitions that has made the name Epic Africa something to be proud of as a start. We want to be proud all the way, right? But we do have some output so far to give you insights on what we're actually doing. So from the first stakeholder engagements that we actually started with already in Accra during the kickoff, we have continued to dialogue. So if you met once, it's easier to dialogue with other means digitally to deliver the first transaction objectives. That will now be a starting point for further transition discussions. So it's about to detail them. But these objectives are some of the things that have been seen as important. Thinking about transition, ensure access to affordable, reliable, sustainable, and modern energy for all, which could be the central part of when you're looking at these Volta and Tana River basins as sources of energy production. But you see that this is only one objective. Then we have the other objectives specified to end hunger and achieve food security, and also improved nutrition and sustainable agriculture comes with that. In blue, I have written some of the indicators we are envisioning down the line. So to be able to say that, yes, we have reached the transition objective 1, these will be some of the indicators that we will be looking at. And that requires to settle this issue about data availability. Number 2 is ensure availability of sustainable management of water for drinking and sanitation. So those are part of the indicators. We have the energy 1, and here it's about energy productivity, percent renewable energy, energy imports, percent of household income that goes to purchasing energy that you need, and things like that. Combat climate change is about greenhouse gas emissions, but also pinpointing the economic loss due to climate change impact. And then fifth objective is to protect and restore ecosystems. It's about sustainable management of forest and, again, halting biodiversity loss and so on. One of the examples that were shared with us was the increase when you dam up the river like this. The increase of bugs is enormous because they have this still body of water to hatch, and also the bugs shifted from just mosquitoes to other creepy crawlies that I don't even know by name. But these are the types of things that I, as a researcher thinking about the Sustainable Development Goals, to hear these very practical impacts is very informative and educational. With these transition objectives, we will continue the discussion with the transition space. People have signed up for being part of the transition space, and these are people not necessarily part of the partners in the project, but from other important institutes and companies and so on. They sign up as themselves. So we have had a wish not to have somebody who cannot speak for themselves. They need to be experts in these areas, but they must not be prevented from speaking by some hierarchical structure, like I have to go and ask my boss if I can say this, because then we won't get anywhere. So they sign up as persons who happen to be attached to an institute or company or others. Also, speaking of data, we're setting up the Epic Clues Data Observatory, and this is led by the Kenyan Agricultural Livestock Research Organization, KALRO. Here when you're doing these integrated assessments, you need to know a lot about the crops growing and the yields and how the amount of fertilizer needed, and on the water side, similar things, and on the energy side, about a lot of demand on various detailed levels, emissions per energy source, and all these types of things. And there exists part data, fragmented data. Quite a bit of data is also open globally from various sources. And in this observatory, we will make it easy to find these resources. And if they are open sources, we will link directly there. But then if we can penetrate further, we think that there's going to be also data that, at least for now, the governments or the organizations are not willing to share, and then there will be behind a login page where additional data might be. Let's see. Okay, so the data we need, among other things, for building our models. And this is where KTH come in, where people in my team, I will lead the work, not do the coding myself, but where we will come in and do the modeling. So we will set up a long-term infrastructure optimization model to satisfy energy demands in these regions, while at the same time looking at the impact on land and water resources, and also see how this all can be affected by greenhouse gas emissions and climate impact. So thus we call it CLUES, climate, land, energy, water. Some examples I listed here. You know about the conflict between land use for biofuels, biomass, versus land use for food. We have water need for food, but we also have water-land interactions in the hydrological cycle, and if you change the land by deforestation, for example, you may have different changes in that interaction. Energy for water, so we need to pump and process and treat water. We need energy for that, drinking water, and then we also need water for energy in the sense that we have the hydropower where we need to grow the biofuels and process it, and we have to cool our power plants. So it all tangled together like this. So we will model that, and we're setting up the first model not to look at only the Volta River Basin, but look at Ghana as a whole. In the end, we go to, sorry. Now someone is upset over there, sorry. In the end, we're going to zoom in on the Volta River Basin, but first we need to understand that we can capture the Ghana energy system as a whole. And what we do then is that we start off with the national determined contributions, as stated from Ghana themselves, and take a look at what some of the ambitions are. And it's more detailed than just reducing the CO2 emissions, but just to show you the challenge ahead is that here is the 60 million ton CO2 equivalents 2019 could, if business as usual ran, end up being 100 by 2030. And they have instead set a target to reduce it to 36. But this reduction is to a very large extent, of course, conditional. Conditional meaning that it rests upon collaborations with other countries and financial institutes. Now we have a big problem. Sorry. Nej. I have to cut my hair for next session. And in doing this, so you don't have to study these in details, but it's just to highlight that we are in the process of finding out as much as possible, including data about Ghana electricity system, for example, what resources are available, and including imports. And then we can look at all these resources and for our model put a cap. We cannot just let the model, which is optimizing least cost infrastructure to meet a certain demand, add as much solar or biomass as it can, if that's the least cost option, because then, for example, the forest will be all gone. So we have to, of course, make sense to the input into the model, and here is a big challenge to get the potential approved by experts and stakeholders in Ghana to say, okay, this is indeed a good value to constrain the biomass to this number, to constrain the solar potential in this way, and perhaps they don't want to include certain resources. So we're working on that now, and also finding out all the power plant capacities they have and what's planned for the future. Same thing on demand side, where residential energy demand is just one thing, but there we have electricity demand of various sorts, but also the cooking demand we will look at. And that will come with an increased demand for LPG for gas and also for electricity for clean cooking. So that's the status now, and I'm not showing any results on the model for Ghana, but we are in the midst of discussing with stakeholders to be able to build the model in a sensible way. Last thing we have, and I don't know if we have any African representatives who would like to join, is that we have this EPIC Africa research network that we're also setting up, extending an invitations to universities and research institutes outside of the consortium with partners to come on board and contribute to some of the questions and learn from each other and so on. So this is being set up, and we think that we need to have these research institutes with expertise from the energy system, energy modeling side, but also the water resources side and the land and agriculture side. So it takes some time to build this. Yeah. And that concludes my presentation. And now I will invite my guests, the cliffhangers, and I have two of them. First, we have Associate Professor Mikael Amelin from Electric Power Systems Division at KTH. Yes, so welcome. And Mikael has worked on power systems in general, simulations and so on, but in particular your expertise in rural electrification is of interest here. And then the second guest is Dr. Francesco Gardumi, who is a true expert on this integrated assessment, CLUES studies. You've been part of setting up many country models within this framework, and also engaging with stakeholders to fill the models with sense. And I welcome them up here because this EPIC Africa is now a new project, rather new. We have been going on in 1 year. So I'm curious to know what advice you can give us, what advice they can give EPIC Africa based on your expertise. So I would like to start with you, Mikael. You worked with rural electrification, and now you hear about EPIC Africa. So what comes to mind? Do you have any advice for us?
Yes, there are many things that are coming to my mind when I'm hearing about this project. It seems very interesting. One thing in particular is you had the objective of providing modern energy, access to modern energy for everyone. And what is the approach here? Is it going to be large-scale power plants that are in the planning, or is it also including local power systems? And the reason why I'm asking is that if you look on Europe, for example, when power systems started buildings in the 1880s, they were local power systems. It was an industry that needed power, and they built a small power plant, and that supplied also the surroundings. And it took several decades. The first power systems in Sweden were built in the 1880s, and it took until the 1920s until there was a connection between Stockholm and Gothenburg. So it was built from bottom up with local systems that gradually expanded. And many developing countries are building from the other direction, that you start by building a national system, so you're building a modern power system from scratch. And there's a good reason to do that, because it's obviously efficient. But the problem is that these power systems, they tend to serve urban areas where you have a large demand, where it makes sense to build large power plants and have all the transmission and distribution system. But then the rural areas are left out. It takes a very long time until they are connected. And I mean, now I haven't traveled in rural areas in Africa for a few years. There has certainly been developments there the past 20 years. But according to official statistics, there are still many millions that don't have any access to modern energy. And what I'm curious is, what is the approach to this in the EPIC project?
Yes, thank you. So what I haven't shown here is that when we zoom in on the Volta River Basin, we will also put in a geospatial dimension. And we will know then that here is the existing grid, and if it's going to serve demands that are presently not connected, it needs to be extended and that comes with a cost, right? The other alternative is to have local system, either microgrid, or if it's very remote area, you can have standalone systems, PV with a battery. And what we will do is model least cost of these options. But I think you can imagine that the input we need to describe these systems is very important to the results. What is the cost of extending a grid? And then we also need to listen, so we have the transition space to ideate with these stakeholders. So we need to listen to also what they believe in, or if there are plans for other reasons than just least cost that we need to take into account. So the geospatial dimension will come in, and we will soft link this big long-term investment optimization model to those geospatial tools.
And will you also look on, I mean, there are other aspects related to environment, for example, that building a large-scale hydropower plant with a dam that you saw in the presentation, for example, that has another impact on the local area compared to if you have a small-scale hydropower plant, which is basically that you take the water and lead it another way for a few hundred meters. You might still have a water flow in the original riverbed.
I don't think we're going to go into that detail. We will try to assess what types of environmental impact will come, but more from a descriptive nature and cost perspective, at least for now. The complexity, but what it is also comes with a, so you may have a benefit of electricity generation, but there comes with a cost of lost productivity from the land that you may take into the water system, or biodiversity. What is the cost of that if you damage other types of important lands? That's very tricky. So that will be more on the descriptive state of the project, I think. Very important question, though. You can come with the least cost system, but you have to be aware what happens and where it ends, and what happens to other things, leading to further studies on those areas. I will take that with me, actually. Thank you. You have more questions, or?
Yes. For example, I think it's great that you're building this data portal, because if you want to do long-term planning and optimize the usage of water, land, energy systems, data is crucial. And the more data that is open publicly and accessible, the better possibilities we have to plan, make efficient plans for how to build the infrastructure in the future. And you seem to have put a lot of thought into how to organize data in a good way. What I possibly could think of is that you should also look for data that is missing, not just what is available, what kind of data should be there but isn't there, and is there any way that you can get it?
Yeah, thank you. So I think by engaging by many stakeholders, we hope to build a network so that even if they don't have the data, they would know where to find it. The missing data comes from daring to present that this is the data we have, this is the data we exist, and if we build a model around that, this is the output, which may not make sense, the results, because we're missing something. And then we can have in these dialogues, hopefully, a discussion as to if we could find a way together to find this missing piece of data, we could adjust the modeling tool to better represent reality. Thank you. Okay, so expert on clues. You have worked in many, many countries setting up these models. So possibly what you hear now, nothing is new. But I still would like to know, Francesco, if you have any key takeaways from your experiences that you could hand over to us now so that we can do well when we set forth to reach our objective.
Thank you. Thank you for giving the space. So seeing your presentation, I get very engaged and many points come up, and I don't think we'll have the time here, but maybe starting with connecting to the discussion now on the data, which is very important. I was wondering whether you are touching upon in the project aspects of data governance. Because as I see, so it's a transboundary basin. There's different authorities and different agencies that might have different pieces of the data, they might have different policies, different expectations as to how they share them, how they can use them. I've seen this being part of a big part of discussion in other transboundary river assessments, so integrated resource assessments that we've been part with, for instance, in efforts led by the Global Water Partnership Mediterranean and by UN Economic Commission for Europe in the Balkans, for example. My first question would be about that, and perhaps then if we go up one step, is are you thinking of any, so bringing this all from the level of collaboration between institutions on a project to really institutionalizing this type of assessments, so creating the arrangements within the academic institutions or also the government institutions to embed this type of data gathering and analysis. I wonder whether these are aspects.
Yes, so I would say yes and no to that question. Yes, definitely. Among the academic institutions that are part of this project, and also that engages in the EPIC Africa research network, we will try to have this a governance framework, but work together also as how can we better support to reach these these more higher level institutes, the government institutes, to get them on board as well. And this is because also I think there are so many different practices in all these. For example, the Volta River basin is 6 countries, so they all have different practices internally, and even within a country they have different practices. So we cannot solve that within this project. But hopefully we can send it forward in terms of having a start. And I think why I'm hopeful that we can come with a proposal as a result from this project is because of the transition space where we will have these dialogues. And then, as I mentioned, be able to say that with the data we have, we can do this. Missing pieces for penetrating other important questions are these types of data. So let's work together on a strategy on how we can convince the release of this data to be open. But in the Clues Observatory, we are preparing, as I mentioned, also behind the login area for the project alone, just so that we can be able to get a little further. I think it's also about building the trust. So we need to work with one government institution and show the benefits, and then we can sort of draw conclusions from that and send it onwards. But I happen to know, and thanks to the two of you, that there are many projects working with energy transition in Africa, and perhaps in combine, these projects can make a good headway together.
Thank you. Yeah. Indeed, there's some work on institutional arrangements that the UN Department of Economic and Social Affairs and have been starting in some similar engagements in some African countries. And this brings me to another question, suggestion, comment, and getting your views. So I guess that the choice of the modeling tools here has a clear motivation that you gave, and there is a clear need. But I wonder whether within the project have you also scoped in the local context if and how much and what capacity in using modeling tools, other modeling tools, and there is modeling tools that could be useful for this analysis. And this could nicely open doors for a collaboration even further beyond the project between researchers and between academic institutions where different expertise is brought together and kind of transdisciplinary teams are put together. I was asking because there's an example that came to my mind while you were thinking of one of these projects led by the United Nations by request, is on demand, by request by the Namibian government, the National Planning Commission of Namibia, to get support using modeling tools for integrated assessments to help in drafting the 6th National Development Plan of the country. We've had the luck of being part of it, and within this project at some point we used these similar tools because that was the request. But then one day I was having a chat with one of the lead analysts in the macroeconomic unit of the National Planning Commission, and he was saying, yeah, we work with macroeconomic modeling, with input-output models, and this clues modeling tool of yours is interesting because we could maybe, I think, bring them together and try and see if there are some technically feasible infrastructure developments and investments that the government could look into from a macroeconomic perspective that could help us bring up the GDP of the country, because that's what they have a task to do as well, and lower poverty. And what's the approach on that?
What a good question. Now I have something to bring up in our upcoming annual meeting in Kenya in a few weeks. I will make this inventory as we are there, all of us, just posing the question. We have not said this to be done, so thank you for the advice. What we have been very careful in describing is that we will at least start with existing tools, not to build new ones, because there are existing open source tools to work with, and we will start with those. And we have also said that we're going to be very careful to put in, so in the modeling we analyze dynamics between demand and supply and for all the resources systems and so on. And we have been very careful in describing how we will look at the dynamics that are of interest, that comes from the dialogues within the transition space. So that we have looked at. But we haven't done an inventory among partners. And that becomes even more important for this energy research network of EPIC Africa to do that inventory. So thank you for the tidbit. Okay, so thank you both for valuable insights. I think I have gotten some feedback that I wanted, so I took the opportunity to do that while also presenting the project, Epic Africa. But now I would like to hear from you all, if you have any questions. Yes, sir. We have a microphone so that you will be heard also to YouTube. Thank you.
All right. My name is Joel. I'm a master's student, electric in engineering. So I wish to know the tools you intend to use. Do you think they are the most appropriate tools for the African context?
That's also a very good question. Thank you. So let me say that experts like Francesco, they have been working with these tools for a long time, and they have been applied to developing an energy system infrastructure in many, many countries. But I see them mostly as linear optimization tools, mathematically. And what it is the input that you put into the model and how you describe the systems. I showed this, that we're trying to now figure out how the Ghana electricity system is, how is the Ghana demand in different sectors looking, and what is the outlook for the future. That's what makes it the relevance. Then the tool itself is carrying out an optimization for least cost. We know that least cost is not everything, and this is why we need to bring the results to the transition space and have a dialogue about the results. So now we have a dialogue about the objectives, which will inform the model, it will inform the targets, it will inform the constraints we have in the optimization problem. And then we must also bring back the results and see if they make sense. Are we picking up on the dynamics of particular to Africa? But also Africa is a multitude of very different countries. So we have to have that representation. But it's a very important question. And I think it comes, the other thing with the tools we use is that they are open source. And that we will have our partners in Africa being, I mean, we collaborate on the modeling. So that I think can be a very great learning experience for all. Thank you. More questions? Yes, go ahead.
Hello, Mats Lexell from KTH. First, I would like to compliment you. I like this setup of a presentation where you transparently afterwards ask some persons to look into what you're actually doing.
Yeah,
so
smart.
My compliments to the setup. I really like that one. And then I would like to discuss partly what you also brought up. You introduced the personal persons, and you wanted the personal persons in your
transition space.
Transition space, because you wanted to have unbiased. On the other hand, institutional persons are also very important because they bring the knowledge from the institution and they also bring back feedback to the institutions. So how do you look upon that balance between the personal persons and the institutional persons?
Yeah, so the personal persons for the transition space belong to institutes. So it would be like signing me up as an expert, then I have certain knowledge that I can contribute with. And among one thing that I do have is that I'm a professor in energy technology, I come from KTH. But I'm not representing KTH. So I don't have to worry and go and ask my boss if I can say this, that, and the other thing. It comes from, so Vito, I'm not going to blame Vito, they're very competent. Their suggestion is this: we don't want to end up, when it's this thing that they don't have traditions of collaborating in a structured way on these issues. They are very much aware about the clues issues, the trade-offs between the resources systems, but they have tackled the problems one at a time when they arrive, but to have this structure for planning ahead and sharing data and all, sharing regulations perhaps in the long run, not within our time frame in Epic Africa. And we don't want a situation where somebody is sent from their institution and cannot say anything, because that was a question they hadn't thought of ahead of time. So they need to go back and then come. So it's more to get this mandate, like the institution person can get a mandate from their boss ahead of time. Can I speak freely? Basically, that's what it is all about. But we hope, of course, that these people will bring in their experiences as experts. So oftentimes I think it's the same. The institution person and person, they are the same in many cases. Okay, yes, go ahead.
Hello, Benjamin from KTH. So from your presentation, I understand that community engagement is left to the local authorities in the African countries, but wouldn't like the input be more credible coming from the actual final beneficiaries? So my question is there like a seat on the table, but during the discussions for maybe like a representative from like a local village or something?
Yes, there is. So that's why these institutional expertise are persons, but within that we also can have people who are private people, who are consumers in various ways, who are having on the demand side, having a need. So they are welcome, but I can say that it's a bit challenging finding this group of 10 to 15 people per country that will commit to it. And we rely a lot on our local partners in Kenya, Burkina Faso and Ghana to help on that matter. For the Volta River Basin, we have the Volta Basin Authority. It's located in Burkina Faso, but they are quite experienced in connecting with the local people in dealing with these issues that arise. So we rely on them a lot to find candidates that can help. Yes, we have a YouTube question. Maybe we can try it. Yes.
This is not from YouTube.
No, it's from you.
Exactly.
Go ahead.
So I wanted to ask about, do you consider the infrastructural differences in terms of the application of your technology? That is, there's this whole concept of, leapfrogging, and you do the research here and we apply the, but then some of these researches have infrastructural impact. So if you take a linear growth of Sweden, there was this point someone make a research and then they figure out something, and maybe the government made a policy that changed the infrastructure a bit, and the next research kind of built on that until you reach a big bulb, and then you say, okay, this is something cool. But the system itself has adjusted due to the little researches you did. So there's this kind of infrastructural support for that big idea. But then the whole concept of leapfrogging is that you take this big idea and then you take it back to Africa, where we are still at that point and the infrastructure has not yet changed. So I'm asking whether you have considered this infrastructural support, and maybe if the model you are building is tied to the current data, how does it account for growth? I'm sure the infrastructure will change and and you will need kind of different data. So that's a question. Yeah.
Yeah, so I think it's one of the things that are so very, very beneficial for non-African partners to be part of these projects, because you can, I think we heard yesterday in yesterday's fireside chat about how the Swedish paying system Swish actually came from Africa. So I hadn't contemplated that. And actually I don't think necessarily that the research output that you talked about would be brought to Africa for leapfrogging. I think the innovations will happen in Africa, and the rest of the world will learn in that same way as the Swish paying system analogy. So I think it's an exciting question. Our job is to figure out what we're going to put. So this looks boring and traditional. I don't even know that you can read the letters on the screen, but it is biomass, solar, PV, you know, very existing solutions. So we could put in new innovation just as well, because again, I'm not faithful to the tool. This is linear programming, it's optimization. We can put it in and see how it compares with others, if we can describe it. But the closest to what you're asking, I think, is what you, Mikael, was talking about, whether we would just think of the central grid that for Sweden was built of smaller first and then it became central, whereas in Africa they started central, but then you have remote rural areas where the connection will be difficult. So maybe the leapfrogging there is to not even build the central grid, but make something really smart with the remote solutions. I don't know. We need the African expertise to be here, and we're supporting with modeling. Yes.
Thank you for the nice presentation, which covers a lot of objectives. I don't know, you created this objective after going there and check, or after you have worked with Ghana, or how did you?
Yeah. The objectives was part of I mean, when the call for proposal came, KTH, so I present the full Epic Africa project now, and KTH will not do everything. But TU Delft, the coordinator, who the persons actually have origins in Africa, they have been working in research and development in Africa for a long time, and they put together a consortium of partners from Europe, 3 partners, and from Africa, the other 4 partners. So that consortium was established, and then starting to think about what are some of the knowledge gaps that exist presently, what relevant research could we do? We have discussed together. So we do have some input from African partners, who in turn know their local stakeholders and could go verifying issues. We also have a reference group, which I haven't mentioned, but they should be acknowledged, of a number of institutes that have worked for a long time with Africa. And they have had their say-so. But oftentimes with these Horizon projects, you go out big, you go out with visions, and then that's what I said. Then you come to the 4-year project, you're very excited that you're now going to get to start this, and then you look at the proposal and you think, we have promised a lot. So now it's up for us to deliver. And this is also why I took the chance to pick some ideas from you guys. So thank you very much for that.
Yeah, that was That was very interesting because you covered like a lot of problem in the area. Like for us, we went to do water quality in Tanzania. So we were looking on contamination in water from mining areas. So we went there with our objectives, ready to give to do some campaign to people to tell them that, oh, we have this contamination from the mining, it will harm you, how can we do, maybe how can we treat water. Then the people were not ready to listen at us because they need access to water, and we need to treat water. So I was interested with your objective because you cover, like, you have water access, food and everything, because it is not good to send a certain project to a certain area and they have a different problem, and you are solving a small problem but they have other huge problems about electricity and water. And how did you find the I don't know, because we have little data on climate effect on water system. How is your modeling going to help this?
Well, I think so first of all, I do think that smaller specific projects are also needed. We're not going to be able to go in as much detail as your project would. So if you go broad, you have to cut corners on detail. So it's always a trade-off, and both are needed. And then for the water, we work with, especially TU Delft has experience in hydrological water models and to link that to climate change. Looking at rainfall variations, but also in the ground, what happens with different land types and things like that. So they're in there.
So the model will be heterogeneous, or?
Well, so again, we will do the long-term optimization model, and then we will go into more detail by picking a particular year and study the hydrology aspects in detail from an operational point of view during that year. Trying to look at that year how is it depending on climate change? What's the rainfall, what's the temperature, things like that. Thank you. Thank you all very much. Time is up, and thank you for listening over YouTube. Thank you for coming here in person. Thank you so much for good advice. I think it's very much needed to have these discussions. Maybe we can do it more often. Yes.
May I just also say, maybe we should give you all a round of applause, and and thank you, audience, for listening. I know we had a YouTube question, but we need to close this. I have a small gift to you.
Oh.
So it's some campus honey for you.
Oh.
Thank you for contributing to Africa.
Thank you.
Thank you so much.
Thank you.
And
From the beehives we have on
Yes.
campus. Oh,
thank you so much.
I'm impressed.
Thank you so much. And please take a look at we still have 4 sessions during the African days. So it's lunch tomorrow, lunch Thursday, evening seminar in the evening tomorrow, and also we will end these Africa days with the cinema here Thursday evening. So please take a look at the program, and welcome. Hope to see you again.
Thank you.